My name is Steve. Some of you attended a workshop I gave on Monday. Thanks for coming back. That's awesome. You can find me on Twitter is probably the best way to get a hold of me, at @ppopowitz, P-E-P-O-P-O-W-I-T-Z. There's a lot of Steve Hickses in the world, and I didn't have any Twitter names to choose from, so that's what I ended up with. Email steven.j.hicks@gmail.com. And then, before anybody asks, yes, the slides are available on the internet at that URL, and I'll keep that URL up there throughout the presentation. I want to say thank you to the conference, the organizers, for having me. It's pretty awesome. This is my second time here at DevUp, and aside from the Cardinals, I really like St. Louis. Sorry. I'm from Milwaukee, so big Brewer fan, and I'm really excited that the Brewers edged out both the Cardinals and the Cubs. That was a pretty big deal for me. Hecklers, you can leave now. Yep, we knocked the Cubs out. And then I want to thank you all for coming here. There's a lot of good talks going on, and you chose me, and I appreciate that. Also need to thank the sponsors. If you haven't gone out there to talk to them, please go shake their hand and tell them thank you for making this event happen, because they are a really, really critical part to a conference like this. I am standing right in front of you, so you can tell what I look like. But that's what my kids think I look like. They drew pictures for me. On the left, my daughter, Olivia, she's 7. She drew that picture. On the right, my daughter, Lila, drew that, and she's 10. And if you think this is just an excuse to talk about my kids and show you their artwork, you're correct. I'm a JavaScript engineer, ? I don't actually know, because I start a new job on Monday, and I know I'm going to be doing some JavaScript. I think I'm going to be doing some other stuff too. But for the last, 20 years, I've been doing JavaScript, and I expect that to continue. Like I said, I work up in Milwaukee, live up in Milwaukee. It's a nice about 6-hour drive to get down here. This talk is about patterns, and when I say the word patterns, I'm guessing that at least half of you are thinking about a book by the Gang of Four that talks all about design patterns in software, and it talks about singletons and abstract factories and all those fun things. And we are not going to be talking about that kind of pattern today. What I mean by patterns is just simple things you can do in your code base to make it a little more maintainable and easier to read for someone in the future to come into your code. So we'll jump right into it, and the first pattern that I have is, I call it the use the platform pattern. My kids didn't draw that, I drew that. I am barely better than them at art. So the background for this pattern is what I think is kind of a half joke that a lot of people in React make, and that is React is just JavaScript. It's mostly just JavaScript. It's a little bit of a stretch, kind of. You need to know things about the React framework in order to build things. But for the most part, we're just writing JavaScript code in our apps. So it would behoove us to take advantage of all the awesome features that JavaScript gives us. First of all, there are a handful of helpful array methods that we can use that clean up our code quite a bit. For these array method examples, I'm going to be working with a specific scenario. We're going to start with an array that looks like this. It's got 3 kittens in it, and each of them has a name and a color, a flag that indicates if they love me, because some of them don't, and a really sad flag on a couple of them that I don't really want to talk about right now. So what we might want to do sometime with an array is figure out which specific ones start with a certain letter, or change the shape of them. And we can do that with some code that looks like this. We've probably all written code that looks like this. We've got, at the top there, we start out with an initialized array, and then we loop through the kittens for I equals 0 to kittens.length, I++. Then we grab the first kitten, or the kitten at that index, I should say. And then we compare the color of it, and we only want the gray ones, so we push that kitten.name, because we only want the name of the kitten, onto our myKittenNames array. And then about halfway down, we loop through that array that we just created, myKittenNames, again with a for loop, and we grab my kitten name sub I, and then if the kitten name starts with a certain letter, we decide that that one's our favorite kitten. But we could also simplify this code and write it like this. Here the code is a little more declarative. Declarative versus imperative. Declarative code is code that tells you what something does. Imperative code, like this, tells you how to do it. And when you read this code, you have to focus a lot more on those implementation details, as opposed to this, where you can just look at that, and each line kind of tells you what's happening in it. So we start with kittens, and then we filter out so that we only get the kittens with the color gray. And then we map them to just pluck the name off of the kitten. And then we find the one whose name starts with P. You could do this by writing your own functions. You could do this by importing a library like Lodash or Ramda. But you can also do this with just plain JavaScript. All of these really helpful array methods and more are available in the JavaScript specification for you. Array.map will let you convert an array from one shape for each item to another shape for each item. Array filter will pull some of them out, filter the list down to just a few that you want. Reduce will change your arrays from a bunch of items into specifically one item. Every will tell you if every item in an array meets certain criteria. Some will tell you if one or more items in your array meet the criteria. And find will go and it'll pull out exactly one of the items that you're looking for. The cool thing about this is if you're using modern browsers, you can just use this stuff. The only exception is array.find is not supported in IE directly. But the good news is we can polyfill it for those cases, or realistically, you're probably using Babel in your React app, and that can convert it from this code into code that the browsers can understand. I like using these array methods because they encourage me to write immutable code. And immutable code is more predictable. It's easier to figure out what's happening in your system. I also find that the declarative code is much more readable than the imperative example. There were a lot more lines of code in that first version. Another thing we can use JavaScript for is to improve our prop validation. If you're using something like prop types, often you'll do something like this. You will create a component. In this case, my component is named kitten. It's got a render method, and it's got some props that are going to be passed into it: the name, the color, the loves me, and that sad flag. And then after the fact, you'll just attach a prop types object to that component, where you say, OK, well, the name is going to be a string, and it's required, and the color is a string, and it's required. Loves me is a Boolean, and it's required, and is dead is a Boolean, and is not required. And then we also specify some default props at the bottom there. Those are the values that the props default to if they're not passed in. What I'm not a fan of with this is we're kind of bolting those prop types and those default props on at the end. And to me, it makes it feel like that's not part of the component. So what I prefer to do is use a feature from JavaScript called class fields. And this allows me to go ahead and actually move those default props and those prop types into my class. So now it's clear that this is part of the class. It's a little more cohesive, rather than something that just gets tacked on at the end and you're not sure if that's really part of it or what that's for. In this case, my class fields are marked as static. That's just how you need to define default props and prop types as class fields to make it work. Class fields is a stage 3 proposal. If you don't know a whole lot about the stages in JavaScript proposals, they start out at the bottom. I think it's stage 0, and eventually they work their way up to stage 4 when they're really something that they jump from one stage to the next as they become more thought out and more proven as a concept. And then eventually they become part of the specification of ES, ECMAScript. You can read more about class fields at that URL if you want to. And like I mentioned, I like this pattern because I feel like it makes my components more cohesive when the code that belongs to that class is inside of that class. We can also use JavaScript to eliminate constructors where we don't need them. Here's a case where I've got a checkbox component, and I need to do a couple things in my constructor. The first thing I need to do is bind my handle change event to the correct instance of the component. If you've worked with React, you've definitely experienced that problem. The other thing I do is I initialize my state in this one. So I default the value of loves me to true. Now, what I'm not a fan of in this one is there are simple ways for us to write this code using newer JavaScript features without using constructors. And I care about that because I find that when you put constructors in your code, people use them to do things. That often leads to a lot of state that they attach to things that doesn't necessarily need to be there. So again, using class fields, we can move those things out of the constructors. We can initialize our state with a class field. And we can set our handle change class field equal to a fat arrow function, which effectively takes care of that binding for us because that gets bound as soon as that executes, which happens to be on that instance of the component. And what I like about doing this is I feel like it minimizes an anti-pattern vector. The more constructors, like I said, you have in your code, the more people are going to want to use them. People will look around and they'll see them in the code base and they'll think, oh, in this code base we use constructors, so I'm going to put a bunch of stuff in there. We also get the power of readable asynchrony in JavaScript. Is anyone using promises to handle asynchrony in their code? You probably have code that looks something like this. We've got a function called kitten that we have to wait for that promise to resolve before we do a series of other promises that are chained together. And we're using the then function to chain them. And for the most part with promises, the nice thing is you don't have to do nearly as much nesting as you had to do with callbacks. And that's great. But there's still a few levels that goes deep. 1, 2, 3, 4, 5 levels, and some of those are mostly because of the way that I format my code. But there's definitely a few there that every time you get to one of those indentations, that's a scope in the code, but it's also a scope in your brain. Like you have to think about which level of indentation am I in right now, what do I have access to, what do I not have access to, and what makes sense here and what doesn't make sense at this level. So from JavaScript, we get the async and await proposal, which is awesome. It makes it so that you can read asynchronous code a lot more easily than reading promises or callbacks. The async keyword is attached to a method to indicate that it is going to be a long-running thing that's asynchronous. And then inside of that method, we attach the await keyword to any functions that are long-running that we're calling, or asynchronous that we're calling. So in this case, since we needed to wait for all those things to happen before we could do the next one, our code just looks like this. We await call kitten, and it doesn't actually execute the next line until that call kitten promise resolves. That's the cool thing about async await is it's actually just relying on promises under the covers. And then it just applies some syntactical sugar on top of it so it makes your code easier to read. It reduces the nesting and therefore the cognitive load as you look through this code. So like I said, you're probably using Babel already to compile your JSX into code that the browsers can understand, which is generally react.createElement. You might not know that you are. If you're using something like create React app to spin up an app, it does use it under the covers. And you can go configure whatever JavaScript specifications you want to, whether they're at stage 0 where they've just begun, all the way up through stage 4. You can read about Babel if you want at babeljs.io. My next pattern is called the puzzleball pattern. And this is based on a story from my bachelor party 13 years ago. 13 years ago, I was camping with some friends for my bachelor party at a state park in Wisconsin. Has anyone had New Glarus Spotted Cow beer before? It's one of the most famous actually it's not an export from Wisconsin. It's one of the most famous Wisconsin beers because it's really, really good, but you can only get it in Wisconsin. Sorry, what's that? I did not bring any, I'm sorry. So I was not camping at the brewery, but I was camping at a state park right next to that brewery. And I was really hungover the next morning, and my friends and I decided that we were going to go into town and we were going to get some breakfast. And when we walked into the restaurant, they had kids' vending machines that have like all those crappy little toys that you can put a quarter in and get them out. And my friend Sandeep was like, oh, I'm going to put a quarter in and get something out. And he got out this toy, which is a puzzle ball that had 6 pieces that you could take them apart, and then you had to try to put them back together. And these were the instructions to put them back together. The toy was absolute garbage, complete crap. It reminded me of a lot of the GoBots that I had when I was a kid, which, if anybody remembers GoBots, those were the generic version of Transformers, and they sucked. This thing was garbage, but it totally stuck with me because the instructions said this: let's decompose and enjoy assembling, which is just an awful translation. But who knew that it would stick with me for 15 years? And I'd be talking about it while I'm talking about React. Well, it's because I feel like this is the perfect mantra for doing React development. You want to decompose your app into components and then assemble them. So really, this pattern is about making sure you break your components into appropriately sized pieces. Appropriately sized being the important keyword there. You can make them really, really, really small. You can make them really, really, really large. Somewhere in the middle, there's this sweet spot. And unfortunately, I can't tell you exactly where that sweet spot is. You kind of have to figure it out for yourself. Has anyone read the Thinking in React page on the React docs? This is the page that made React click for me. The rest of you should read it. You will get so much more understanding of how to build a React app by reading that page. I'll give you the TLDR for this. Step 1, you break the UI into a component hierarchy. Step 2, you build a static version in React. Step 3 is finally when you start to think about state in your app, and not until then. By doing this, you're focusing on the components and the boundaries of those components and the responsibilities, and you're able to find the seams on the page where all your components are going to fit. In the workshop that I taught on Monday, I handed out pieces of paper with websites on them, the ESPN site, and then my email from Inbox. And we took 5 minutes to just take a pen and draw boxes around the component boundaries where we thought it made sense. This is the thing that I do when I'm building a React app on a regular basis, because it really helps me figure out where those separations are. So this pattern is important to me because it helps me end up with cohesive components. And things are easier to test when they're really cohesive, when the component does, everything in that component does the same thing or deals with the same concern. They're also easier to read when they're cohesive. Your code reads a little more like an outline, and you can find things versus looking at your code and thinking, I don't know why this is in here. This feels like it should maybe be somewhere else. So like I said, there's a gray area in between too small and too large with your components. You have to make sure you go as small as you can while still keeping things meaningful. I think it's also really important to understand why we're breaking things into components. It's easy to jump to the conclusion that we're doing this for reuse, that we're making these small pieces so that we can just reuse them and assemble them elsewhere. The truth, in my experience, is that the reuse is a side effect of us abstracting things and isolating them properly. You make the right-sized black box, and it deals with the one concern that you give it, you're going to be able to reuse that thing throughout your app. So when you're breaking things down, don't necessarily think about size. There are times where I have an 80-line component. There are times when I have a very small component that calls small functions. Think about the boundaries of responsibility more than the size. My next pattern I call the pragmatic state pattern. Who in the room is using Redux for their app? There's, okay, about a third. How about MobX? 1, 2. Those of you who are using those state patterns, how many of you are using it to maintain probably 80% or more of your application's state? A few of you. Okay, so this one is specifically directed at you. This is what it says in the Redux docs. In general, use Redux when you have reasonable amounts of data changing over time. You need a single source of truth, and you find that approaches like keeping everything in a top-level React component state are no longer sufficient. So how do we end up with code like this to manage a simple checkbox? This is an action that we would create to manage a checkbox for Redux. It's got an action creator, toggle loves me action creator. And then in a separate file, I've got a reducer. And my reducer has a function that, let's see, handles the toggle loves me action about halfway down. And then about halfway down, we handle the toggle loves me action and modify the state based on that. And then we also have a component that you might call your presentational component. That's the thing that is just stateless functional, and it takes some props and renders the stuff. And a lot of times we'll also create a container component that manages all the states, connects it to Redux, and then renders the actual child component, or the presentational component, which isn't on this screen. When, I'll remind you, all of the code that you would need to write to do this using setState fits on one screen. And I cheated a little bit because I made the fonts a tiny bit smaller to make it all fit. But it fits all on one screen. All of it is right there. I initialize my state at the top. I handle a change event and set the state to something new. And then I render my input. This is another thing that the Redux docs say. In the end, Redux is just a tool. It's a great tool, and there are some great reasons to use it. But there are also reasons you might not want to use it. Make informed decisions about your tools and understand the trade-offs involved in each decision. Redux is a tool, and it has its definite uses. But you need to make sure that you're using it in the appropriate place. And that place is probably not for the entire app. So use setState if you have one component, and that's the only component that needs to worry about that state. Use setState and elevate it to a component that's higher in the tree if you've only got a couple components that need that state, and they're closely related. When you've got a bigger tree of components, and that red box at the top is where we need to manage the state, and the bottom gray ones are all the places that need to interact with that state. When you've got a bigger tree and things are further apart, then use something like the React Context API to connect all those pieces. Or now's a great time to use Redux to connect all those pieces. But I don't recommend using a hammer to drive screws or a screwdriver to drive nails. Use the appropriate state management tool for the job. One of the reasons I really like this is because it eliminates some Redux boilerplate. That's the big dig on Redux, is that you end up writing a lot of boilerplate code. Simple components like that checkbox are easier to understand when all the code is in one place. It's very cohesive. And a cool side effect of that is that when I do this and I use Redux only for things that are application level states, I can see a Redux action creator or reducer and know this is a thing that has distant side effects or is used throughout the app. And it gives me a clue as to what that state is used for. My next pattern I call the integration pattern, and this has to do with testing. This is the testing pyramid. Who's seen this before? Hands in the air for this. For those who haven't, this is an idea put forth by a gentleman named Mike Cohn, and the idea is the different types of automated tests that you write in an app have trade-offs. Some of them, unit tests at the bottom there, are really easy to write, inexpensive to maintain. You can just blow a bunch away and write a whole bunch of new ones. You can change the ones that you have. Unfortunately, the drawback to that is that they don't give you a whole lot of confidence that your app is functioning properly. On the other extreme, on the top, UI tests, they give you all the confidence in the world that your app is working because you're using a tool like Selenium to actually fire up your website and click through and do things. Unfortunately, those UI tests at the top are really, really slow, and they're difficult to write, and they're really hard to maintain. And I'll be honest, I don't know how to do good UI tests, so I don't write a whole lot of them. Where I like to focus my area is in what I call the integration zone. This is somewhere in between unit tests and integration tests. What I've found is that unit tests can be really, really small, sometimes too small that they aren't adding a whole lot of value. Integration tests, which are the other tests that I really like to write, often depend on things like APIs and databases, and that makes my tests run slowly. But I still think that I can learn a lot about my app by using an integration test that doesn't actually call the API or the database. A lot of people will get really dogmatic about what is a unit test and what is not a unit test by looking at the number of units in the code. Like, is it literally one file? Are you testing only one function, or are you pulling in a bunch of other functions? I don't much care for that argument. But this is why I like to focus on the integration zone, because then I can just say, I'm going to render this component, and it's going to have the entire component tree. I'm still going to mock out my database and my API, because I don't want to deal with those things. And I'm going to write tests against all of my components interacting with each other, but with some fake data provided. When you're writing a lot of tiny unit tests, that makes it harder to refactor. So this is one thing that I like about using this integration pattern. It's easier to refactor things because those tests that I have that test an entire tree of components or functions, I've written those tests at the top, and I don't have to worry about the implementation down the line of like which function exists where. I also get a good amount of confidence from these tests, not as much confidence as I would get from a UI test, but I get a good amount of confidence because they are integration tests, sort of, almost. The next pattern I used this week. I packed a suitcase to come here. Some of you probably did the same. And when you packed a suitcase, if I were to guess, I would say that you packed your suitcase probably like this. Oops. Here we go. You packed your suitcase like this. You grabbed all your pants out of the drawer, and you put them in the suitcase. You grabbed all your socks that you needed and put them in the suitcase. You grabbed all your shirts and you put them in the suitcase. You grabbed all your underwear, which I'm not showing you, and you put all that stuff in your suitcase. You zipped it up. You drove down here, and you got to your hotel room. You unzipped your suitcase, and maybe you're the kind of person who likes to live out of your suitcase, and you just left it in there. You're monsters. I like to live out of the drawers, so I transferred it from the suitcase, pile of jeans, into the drawers, pile of socks, pile of shirts, pile of underwear. There's overhead in this the next morning when I have to figure out what I'm going to wear. I've got to go dig around, and I grab a pair of jeans, and I kind of mess up that pile. And I grab some socks, and I kind of mess up that pile. And I grab a shirt, and I kind of mess up that pile. And by the end of my trip, it's just a mess of clothing. Kind of looks like that. One day, I realized that I didn't have to pack my suitcase like this. I could pack my suitcase as outfits. So now, in one pile, I put my shirt, my underwear, my pants, and my socks. In another pile, day 2, shirt, pants, socks, underwear. Day 3, shirt, pants, socks, underwear. And now, the next morning when I wake up, I open the drawer and I grab a pile of clothes, and I'm good to go. This talk and this pattern have nothing to do with clothing. What I'm really talking about with this is how we organize our code. We have this history of grouping things by the type of garment that they are in our code base. So we put all of our components in one folder. We put all of our styles in one folder. We put all of our actions in one folder, our reducers in another, our API client functions in one folder. The problem is when we get a bug because someone can't log in, it's not like everything in the components folder is broken now. We have to go look for the login stuff. We have to look for the login pants and the login shirt and the login socks in all of those different folders. And we're bouncing around through our app trying to figure out why this is a bug and why it's not working. On the other hand, if we organize our code by feature, we put all the registration stuff together, all the login stuff together, all of the kitten form things in one drawer, all the feed kitten things together. Now when we get a bug that the login page isn't working, we just go straight to the login folder, and everything is right there, and that's how we can fix it, is just by working in that one folder. This pattern is important to me because it means that I spend less time looking for the different pieces related to a specific feature. I'm putting my code together that changes together. The next pattern we're going to talk about is called the ducks pattern. This is the only pattern that actually has a legitimate name that I didn't give it. Somebody else named it the ducks pattern. I'm not the only one that's bad at naming. So the ducks pattern is basically the suitcase pattern applied to Redux. If you're using Redux, you probably have an actions folder, and in that actions folder, you've got some actions related to kittens. So here you put them all in the kittens.js. And then you also have some action creators, so you put those in the action creators folder, kitten.js, and they all sit there together. And then you've got reducers, and so there's a reducers folder, and you put all the kittens reducers in one file in there. The ducks pattern applies the suitcase principle to Redux with a few operating rules. A module must export default a function called reduce, or reducer. It must export its action creators as functions, and it must have action types in the form module/reducer/action type. That link will take you to a description of this ducks pattern. So what this looks like is now I have one file in my kittens folder, and I call it state. Some people like to call it ducks or duck.js. And all of my state management things for Redux go in here. So at the top, I've got my actions. I don't actually need to export any of those actions now, because the only things that are using it are inside of this file. I've got my action creators. These get exported as named exports. I'm going to use those throughout the app. And then I've got my reducer, and that gets exported as default. So again, with this pattern, I spend less time looking around through my code, trying to find the different pieces that are related to a specific feature. And I've put my code together that changes together. Pattern number 7 is the blueprint pattern. If there's a common thread through all the things I've been saying, it's to be pragmatic and thoughtful about every tool that you use in your app. Never mail in a decision on anything. Always think about the decision that you're making on which tools you're using and why. The problem is that this takes a lot of time and thought to do this, and we just kind of want to It's our nature to put it on autopilot and have these decisions just ready to go and not have to worry about them. So the solution for me is to do a good job of maintaining that decision-making process in your README file. Define a blueprint in there of how someone who's coming into this app and wants to figure out whether they should be using Redux for this particular component or they should be using state for this component, they can make that decision. Here's an example of something that you might put in your docs for our state conversation. Choosing a state management mechanism. Does only this component care? Then use set state. Do only a few closely related components need it? Then use set state and elevate it to the lowest common ancestor. Is it state that the entire app needs? Use react.context, or whatever it is that you're deciding that you're using for app level state. Here's some things that I like to see in a README. Frequently asked questions. There probably are some, and if you don't have them documented, that means it's just tribal knowledge. A project goal that will help me understand why we make certain decisions. Some guiding principles to help me make those decisions on my own. What do we prioritize in our code base? Do we prioritize performance, readability, extensibility? You can't say you prioritize everything, because just like in life, that means that you don't have any priorities. So you'll probably get like 1 to 3 priorities that your app cares about the most. And any existing decisions that you've already made, document the reasons that you made those decisions. This talk is about maintainability. And I think that you can summarize maintainability by the sentence, making it easier for people in the future. Not the cyborg people in the future, years from now, but the people in the future who have figured out how to grow a sweet mustache a few months from now, and they've come back into this code base after taking a little break and working on something else, and it's been 3 months since they looked at anything and they don't remember very much about this project. And is this the one where we used Redux for everything, or is this the one where we used Redux just for app level state? If you put it in that blueprint, you give that person, who happens to just be you 3 months from now, you give them a good idea of how they can continue to make decisions and how the app should keep evolving. My final pattern is called the pacifist pattern. And this is a person that died on a hill. I don't really know how to draw that, but that's what it looks like to me. How many people in this room have had an argument with teammates over code format? How many people have had someone on your team commit changes that were nothing but code format changes? How many people were that person that made that commit? I'm also raising my hand. More importantly, we're talking about JavaScript, so it's survey time. Raise your hand for tabs. Raise your hand for spaces. Tabs won out. But that's an old argument. The cool argument now is raise your hand for semicolons. Raise your hand for not semicolons. Monster. Well, I'm really excited to tell you that I have found the answer to this problem of arguing over code format. Who cares? Why are we honestly wasting our time on this stuff? We shouldn't be. We should focus on other things. Years ago, this stuff mattered because it took a really, really long time to go in and put the semicolons on all the lines if somebody forgot to do it. But we have tools that do it for us now. One that I really, really like is called Prettier. If you're not using Prettier, you should definitely check it out. You should get your whole team on board with it. Prettier is an opinionated code formatter. It has sensible opinions. And it's got plugins for all major code editors. So what it means is I can write horribly unformatted code like this save the file, and it formats on save, and it ends up just immediately looking beautiful. I know what you're thinking. You heard me say the word opinions, and you've got opinions. And you want to know, what if my opinions don't match Prettier's opinions? Semicolon people, where were you? It was pretty much everyone, right? I fixed it for you. I'm sure that was driving you crazy. But seriously, it's pretty configurable. The opinions are really, they're sensible opinions, but if you don't like them, you can configure them to your liking. So this is a really important pattern to me because it ends those senseless arguments of, no, we need to indent that 2 spaces instead of 4 spaces, or 4 spaces instead of 2 spaces. Prettier is definitely opinionated, but the opinions are they're good opinions. They're sensible. So we never need to worry about formatting our code again. We just use the tool to do it for us. We spend less time bickering about if it looks right or doesn't look right. And now we can worry about things that matter, like what color we should paint the bike shed, which is always a super important question. I want to thank you all for your time. Thanks for coming. I will be off to the side here. You can come talk over here and ask me questions. Enjoy the rest of DevUp.